All right. So first off, thank you to everybody who came. It's always a pleasure to have you guys here. So we are Purdue Hackers, and we will be hosting the GDB Workshop. So, okay. So two things over here. I've been saying this throughout, but scan both the QR codes, have the links, especially the one on the right. And I'm gonna have this on the screen for like a minute and a half. So scan the so type out the Breakpoint link. It's gonna take you to Google Docs, which has the GitHub link. So just get those things. I'll have this up for a minute or two. So
are you emailing the attendance or resources? Can you email it?
Yeah, sure.
Oh, I've already sent it. Oh, never mind. Oh.
Yeah. This space out here. Yeah. Okay, yeah. Let's place up there. Yeah.
That was all
All right. For those who just joined, quick couple of things. One, scan the QR code on the right for the attendance. That's like Purdue requires us to do it. Please do that. And the left one is for the resources. It contains the Google Docs, which has the GitHub, which has a cheat sheet. There are a couple of hard copies, there are many cheat sheet hard copies out here. So feel free to take that. We have water, we have snacks. So yeah.
My favorite part about this presentation is I get to see you with two angles.
Has everybody got this scan? At least the attendance link? Is anyone who hasn't? All right, let's start with it. So a little bit about me. So I'm a junior in computer science. I'm in the machine intelligence track. A little bit about me. I like playing the guitar. I love hiking and I love string dancing. If you guys want to connect with me, my GitHub's right there, and as is my email, and you can probably see the person I am just from that photo. So here's the cheat sheets. The links are in the Google Docs thing, so I'm not going to have this up, but whatever. So how have you guys been able to clone the GitHub repo? Has anybody not done that yet, or has had an issue doing that yet?
Data is kind of running slow for me.
Data is running slow. All right. I'm just gonna give you guys like a minute and a half to just go log in SSH into data. So like it shows over here SSH username data.cs.purdue.edu. Git clone the links in the Google Docs, and I'll just give you guys like a minute to finish.
It's like pressing.
Yeah.
What's up? What's up? Google Docs is not loading. Oh, I thought, wow. that is bad. That's gonna be interesting.
Is the repository public on GitHub? Like,
Come again?
if I want to, is the repository public on GitHub?
It should be.
Okay, just wondering. Is there some reason I can't copy it? I don't know why. Yeah, it's not copied.
I think it's more of an internet issue with.
Yeah, so I was gonna try to go to your GitHub.
Yeah, just go to GitHub. That's interesting. Have you guys been able to clone the repo? Okay, so it's public. That's not an issue. So I'm gonna suggest how you guys stay on edge on, like maybe help you guys be an idea of how to be on cloud. You might just like switch it off. If you guys are having issues,
I don't know how to get on to Azure.
it's the same credentials as your cloud 2.0. It's just weird. I'm really, yeah, I was not expecting cloud 2.0 to be like icky today, but such as life. Okay.
134, right?
So actually, I'm just gonna go back over here. So those of you guys who just joined us, sign the attendance. If you do it later, it's fine. I'll just put it up later and type this URL out because that's where, like, you know, all the resources are. I'm sending it to you.
Like for Purdue, like your email.
You know how many minutes it's been?
Get the SSH into the schools, like,
Are you guys not able to explain?
I don't know how to use like PowerShell, so.
Okay, I'll just show you guys. I'll show you how to do it. I'll show you. So the way you do it in Windows, or if you guys are on Linux, I think you guys can do it, but for Mac, just open a command prompt, or for Windows, just open a command prompt. Just type in SSH, so your username @data.cs.purdue.edu. Put in your password, it should be able to log you in. And if there's an issue with data, so this is like a cheat sheet. This is a pro tip. This is not, I did not say this. You can actually log into any of the computers in the building. So for example, my preferred computer is Azure 15. Don't use Azure 15, that's mine. But you can put in any number. So you can do, for example, the way I like to do it is Azure 15, and it's gonna let you log in. But if there's already somebody in there, it's just not gonna let you. So right now, no one's using Azure 15, so it's letting me use it. Quick pro tip, not part of the workshop though.
So are they all called like Escher and then a number?
Azure number. So like all the CS labs, every computer at the bottom has a name and a number. You can use that if data is never working. That's a neat pro tip, which I did not tell you guys, because I don't think you're allowed to do that properly legally.
You're on live TV.
I know, I'm recording it, but oh well. I'll edit it out. Matthew, just remind me to edit it out.
I'm not gonna remind you, you're on live TV.
Is everybody able to get, was everybody able to get it set up? Still can't? Bro, I think it's fine.
Oh, wait.
Okay,
Yeah, that's.
okay, people who haven't gotten it, could you raise your hands so I can actually see?
Okay.
Who haven't been able to get it
Oh.
so far? So, okay, just keep your hand. Matthew? Fennel, could you just go around helping people who have their hands raised? All right, I've got people over here, what are you doing? Yeah.
I would say I would not
Are you
receive.
connected to Cloud 2.0 or? Yeah, so you got to connect to, yeah, to switch into the 40 thing, you should connect to Cloud 2.0 or Azure.
Just dumb question at the moment.
Oh, just put in your 40
This is
password,
something
so not pin password.
No technical. I just need experience. Yeah, I know that thing.
That's good. At least we're in the same boat.
Okay. How did you find out?
Okay, okay, so for those of you guys who are having issues with this, I kind of thought this would happen, but oh well, I didn't want. Okay, go to Replit. This is such a hacky way of doing it, but Replit gets the job done. So just go to Replit.
Unrelated, like, so do we have to assess it only to CS communities? Can we assess it to like ECM? Because I know that they also have GDB.
I am not sure. I know the extra, I know one's in the CS building for. I don't know about the others. I haven't tested it. Okay, so for those of you guys who haven't been able to get it working, just go to Replit, Google Replit, just continue with GitHub, continue with whatever, like Google or something. Why is there so much? Yeah, yeah. Okay, so get into Replit. If you can't get SSH working, create a C Replit, call it whatever, hit create Replit. It should give you the shell over here. So you just click on the shell button. It should give you an access to the shell. It should give you the access to the code editor here. You can use git clone. You can do the thing just as you would in the shell, as you would in data.cs. I was not expecting. Anyways, for those of you who have been able to, let me just actually remove this. What am I doing? Okay, so I'm just gonna show you guys how it should be doing, looking, whatever. So here is the Git repo, so you can just copy this. Hit Git clone, so just paste this, like this always being an issue. Whatever, paste it, and you should be able to just CD into it. Don't worry about the team up thing. Okay, I'm gonna let you guys get that set up, but in the meantime, you can just get started. The initial parts don't depend that much on this. So again, welcome. I'm just gonna skip over some of the intro slides. So if you guys have ever used C files before or C++ or any of the variants, you know that the C files are first compiled by GCC into machine executable files. So the flag you need to use to be able to use GDB is the -G flag. There are a number of other flags in GDB or GCC. We don't care about them right now. Do whatever you need to use the -G flag. That's all. So, okay. So first off, a little bit about GDB, what it does. So if you want to have a C executable, you need to go through a process called debugging. Okay. You can do that later. You can do that later. Right now, it doesn't need it to. I'm just gonna show it on my thing. You guys can follow. I don't know. You guys might want to pay attention first, and after that, when I'll let you guys do it, then I can go on helping everybody out. So what GDB does is it allows you to debug your code. So oftentimes you'll have logical errors, you'll have runtime errors. That's really hard to figure out. That's really hard to debug with C, because C is a very low-level language. It's like the barest abstraction about assembly, which means it's not super helpful. So you need to use these tools like GDB to help you around. So the cheat sheet I've given you covers most of these commands, especially the top portion. The more you guys kind of get, familiar with the top stuff, you can move over to the bottom stuff, which is like even more powerful tools you can use. This workshop is pretty much gonna be an explanation of this cheat sheet, how to use it. So first things first, the way. Hold on. Okay, there is a little. I think Rachel messed this up. Sorry. Notice this. My apologies. But okay, so when you actually enter GDB, you need to run R to actually execute your code. There are all these different commands you can take a look at. So C is for continuing, S is for stepping, N is for going to the next command, and Q is for quitting. I'm going to actually explain these better. I'm just giving you guys a quick overview right now, like quick 32-minute explanation. You need to add breakpoints. So what breakpoints do for you, for those of you who don't know, is it executes your code to a certain point and then it stops. And then it gives you control back to you. So you can slowly figure out what you need to, what's happening, and you can go line by line. And then here, you can disable the breakpoints, you can enable them, you can clear them all, doesn't matter. And we can print the variables to see what's happening. I'm going to explain this stuff properly. Now I'm actually going to show it to you guys using the terminal. You guys don't have to follow along. This is just me showing you right now. So we have three, apart from the README, we have three C files I'll be showing. So first we'll be taking a look at the basic example, which is where I'm going to be demoing all the basic features. So for those of you who have taken C and those of you who have never taken C, it should look pretty familiar. It should make more sense if you're taking any coding class. The syntax is very similar to Java. So just running through it line by line, you have a main function, which is where it enters. You initialize a variable called A, which is an integer, and you put the value of 9 in it. B is a pointer to this integer A, and it's represented like this. This is the address operator. You don't have to worry about it if you guys don't know about it, that's fine. We call this function called print hello world. We pass in this integer, and you just print out hello world with the number, and we just return a 0 at the end of it. Should be easy. I'm just going to now step through it and show you how actual GDB works. This code does not have a problem, but this is just for me to run through how to use the different things in GDB, and then I'll actually be showing you guys, how do you actually go about debugging, like the second file. So the debugging example, that's where I'm going to sit down. I'm going to show over here how actually you can go line by line, helping you figure out like a real example code. That code is literally taken from one of my labs where I screwed up many times. So it's real. So the way you compile C files, for those of you guys who don't know it, is gcc -g. This is the flag we need to tell GDB, like we should allow it to debug. We need to put in the file name. So over here that was basic example.c. -o gives you the output executable, like you can give the name of the executable that you create. So it doesn't need to have a file type, but I always like to give like .out. So I know just for my reference, it just can be like A or B or anything. As long as it's a valid Linux file name, it'll be fine. So I just compiled it, and let's just run it and see what it does. And as we see, it prints hello world 9. Just as we expected, no monkey business going on over here. So let's actually see how GDB works. So in GDB, I'm gonna say GDB and the name of the file I want to like debug. So I'm gonna say GDB a.out, and it's gonna give you like this whole license thing. Ignore it, doesn't matter, no one cares about it, right? So what you have now is where the actual stuff begins. So the first command you're going to see is all. So all is just going to run it. So as you see, it tells you it's starting the program. It runs the program, in which case this just prints hello world 9. And it just like says like, oh, the process exited normally. Normal stuff, nothing funny going on yet. So let's just try and stepping through the code, I'll just start showing you the different features. So say there's some issue with this code, and we want to go line by line from the very beginning. All right, we can do that. So what we can do is say break main, and that will set up a breakpoint at the line. So over here we see it says the file. So basic-example.c at line A. You see it shows over here. It's basic-example.c at line A. So you can give it like file names and line numbers. You can give it line numbers. You can give it function names. It's crazy powerful. It's really cool to use. So for example, if I did not want this, I could just set up a breakpoint with an actual number, like the line number. So I'll say breakpoint line number 9. Say why not? So I do breakpoint basic example.c line number 9. So it's going to set up a breakpoint at line number 9. Now the good thing about this thing is you can also add breakpoints with conditions, which I'll show a little later. So we will, yes.
Could you increase the font?
Oh, okay. I'm sorry. I did not. I'm trying that. It generally works, but no, it really. Okay. Edit? No. Properties. Okay, font. Okay. Okay, is this better? Wow. Wow. Okay. Okay, we need to go a little down. I can't see it on my screen. Let's try this one. Yeah, this. So resizing always just messes it up. Best way I have known to do it is just close and then open it again. Probably better ways to do it. I don't care. No snatchy, please. Don't worry about the team ups thing. That's just what? Oh, it was an extra 15. God damn it! Why doesn't it?
What's the link?
All right. Is this better? Can you guys see it? All right. Sorry about that. I did not see. I did not notice that. Anyways, so you can. That's an interesting thing, but okay, let's just get started. So I'm just gonna say run, and it starts running the program, and it still shows over here that it's stopping at breakpoint 2 at main basic example line number, and it gives you the actual line itself. Now, here's a big thing you need to know about GDB. The line it shows, it's the line that hasn't been executed yet. So that means that we have not yet entered main. We will be entering main right now. So I say next. So the actual command is next, but like who typed the whole thing, right? We are CS people, we like shortcut. We just type it in, it works. So it just allows you to go to the next line. Here you don't really see it because there's also a breakpoint, but whatever. So what you can do is you can go line by line by typing in next, one after another. So we were at line 8, we are at line 9, now we are at line 10, we haven't started executing line 10 yet. Now, cool thing about GDB, you need to oftentimes just go through like a million lines. Instead of typing in N every time, just hit enter. That works. When you hit enter, it re-executes your previous command. So if you had like say something that said step, it's gonna step in even if you don't want it to. Anyways, so that's that. So now, how many people over here do not know the difference between the next instruction and the step instruction? Please raise your hands. There's no shame in it. Okay, no, it's all good, no worries. So I'm just gonna show you guys what the difference is. When you're doing next, what you do is you go to the next slide. Pretty much that's it. It does not care if there's a function being called inside, if there's anything weird being done. It does not care. But when you say step, it allows you to go into functions. So to give you an example, say I am right now at line 11. Here is where I'm calling the print hello world function, correct? So if I hit next, what do you guys think is going to happen? It's going to go to the next line, correct? So it just went to the next line. It says hello world 9, return 0. Exactly like we'd expect. Now let's start the program from the start. So when all means it's going to start from the very beginning. So here are the breakpoints. I just step to them, whatever. Okay, next to them. Now we are over here. What happens if I press step? Jump into the function, correct. So when I hit step, now over here it shows that it's switch context. Now it's inside the function. Does that make sense? All right. So again, this is something that trips me up every day when using C. I hate it, but this line has not been executed yet, which means C does not know the value of number. So if you try to print the value of number right now, it's going to be some random gibberish. That's not the number we have, but number has not been declared properly yet. So we need to go inside the function, and then when you print the number, you'll see the correct value. So always remember that the line you're seeing has not been executed yet. At least when you're starting off, the more you get into it, the more exceptions start cropping up or whatever. So that's what we have so far. And now an issue with this often becomes that, well, sometimes you are at a function and you want to know how you got to the function, right? You can't remember it when you have like code that's like 1,000 lines long or whatever. It starts becoming harder. So GDB has this command called where. So when you hit enter over there, it shows you a stack trace. So the stack trace is going to be how the layers on which your command is like being called. So I'll show you a more robust example, like in the actual debugging exercise. But over here you see we called from main, we called print hello world over here, and it was at line number 11 that we called print hello world, which you can see is line number 11. And over here we see we are currently at line number 4. So where is super cool that way. Another quick thing. So you oftentimes won't be able to switch a lot between the code that you have open and like the terminal. So there's a quick little thing GDB has, which prints out the code where it's currently at, the code around it. So the list command allows you to do that. So right now, for example, at line 4, here's where we are at. It shows a couple of lines on the top. It shows a couple of lines on the bottom. It's super helpful, especially when you have some weird, complicated, nested functions, loops, whatever. Helps you out with being able to see what's happening. Super useful commands over here. Okay, let's just switch back over here, seeing what all do I need to show you guys. Stepping next, continuing, that's fine. Breakpoints, okay, yeah, disabling breakpoints, that's also okay. Web frame, okay, cool. Now I'm just gonna show you guys a couple of things. So you see over here, so C has this thing called context. Every language has this. So when you have the main function and you call the sub function, you won't have access to the scope of the variables in the main function. Does that make sense? You guys have done scoping in Java. I mean, I'm assuming you guys have. If you guys haven't, you can't access a variable in another scope from a different scope if you aren't authorized to. So in C, what you can do is with GDB, you can switch scopes. For example, over here, say, okay, let's go over here. We see we have this variable A. Right now, we are in print hello world. What do you guys think is going to happen if I say print A from inside the GDB terminal right now? Are there any guesses?
Random.
Come again?
Random numbers.
All right, that's a good guess. Let's see what happens because I don't know what's going to happen either. So it says no symbol A in current context. Neat thing about C is because it's just one layer above the machine instruction, sometimes it actually will print a value. It's super weird, so it's on you to be careful. That's all the bad things about C, I think, but that's what makes it fast. It does not have any safety built in. So it says there's no A in current context. But what if we want to print A? Like we want to badly. What we do is we switch frames. We tell GDB to go to frame 1, so where the main function was, and from there we can print A. So for example, if I do frame number 1, so 1 is the main frame. I hit that, it says, okay, so this is the line where we go at. And now when I print A, what do you guys think is going to happen? Okay. Correct. That's what it's going to do. So that is GDB in a nutshell. These are the main functions you'll be using every day, especially in higher level classes. So say, which class even gives C? 250, 252. I'm guessing a lot of you guys are taking 240. So you're going to be using this a lot, but these functions will take you a long way. All right. So let's just let it continue. So C is just continuing. It lets the thing go, keep going. Are there any questions so far before I go into the actual example?
Yeah, so how did you decide frame 1?
Okay, yeah, good question. So, well, if you're doing with general terminal, you won't be able to scroll up on. I'll set it up in a different way. Anyways, so you see I ran the command well over here, right? So that tells you, where did that go? That is here. Okay, it tells you over here. So it says 0 is the function called print hello world. 1 is the function called name. So keep jumping. Does that make sense?
Yes.
So different functions will have different numbers. You'll have to run where and then check the frame. All right, next question.
Wait, so before you call it frame 1, were we in frame 0 and that's why?
Yes, correct. Okay, yes.
What is the P number doing?
P number. Okay, it's printing the variable. So P is short for print. Okay, whatever. So if I were to run this from the start and next, I could type in print A, or I could just say PA. Both, so P is like a short form.
And is there any way to go to the previous line?
No. So the way GDB and a lot of these things work is that once you do it, there's no going back unless you run from the start. There are exceptions to that. You can do you can tell it to save state at a current thing, at one thing, and then you can go forward. I don't know how to do it. I've heard people using it. I feel it's way more complicated than what needs for all levels. So I think that's gonna be fine. Yes.
Can you jump into functions that come from object files? So like if they give you an object file and you have to compile to it.
Yes. So that's actually you can do that as long as it's compiled by the -g class.
Okay, so if I had like object file 1, object file 2 -g, then I can jump into the functions from other object files.
Yes. So in C doesn't have the concept of objects, but what it does, it has a thing called linktr. It's gonna link all your files and functions together, and that allows you. So you can do that as long as the function names are unique. But if it's not unique, GCC. So the compiler is gonna shout at you like, "Hey, I don't know which. If you say this name, what do I resolve it to? This file or this file?" So you just gotta be careful. C is hands-off. C does not have the safety of Java. That is something you have to get used to. It's a sacrifice you need to make for speed. All right. Are there any other questions? Going once, going twice. All right. So now I'm just gonna jump into the actual example where I'll show you guys how to debug. So, okay. Do you guys know malloc in C? Yeah, you guys have, no? Okay, how many people know malloc in C?
Heard of it.
Okay, that's gonna be interesting. So, I guess I'll be teaching you guys some malloc today too. That's gonna be fun. Okay, so this is So this file is it's got one main function and it's got these three functions. I know it might be a little weird if you guys haven't seen C before. The way I'm just like telling the function name and then I'm initializing them later. C is weird. Get used to it. That's really all I got for you guys. I'm sorry. So, anyways, let's just run through this program, just on a very overview level, and then I'm gonna like shout at me if you guys don't understand something, because there's probably gonna be a lot. I thought you guys knew malloc. I'm sorry. I should have done my homework better. Anyways, main function, simple stuff. It calls three different functions. It calls initialize array, it calls copy string, it calls bubble sort. I'm hoping you guys know bubble sort. So what initialize array does is it goes to the array and it initializes the numbers 0, 1, 2, 3, and 0 at the end. 5 numbers. Simple. That's what it's doing. Copy string. It takes in your string, it creates a new buffer for the string. I'm going to explain the buffer concept in a bit, but it's going to copy that string into that, and it's just going to return the string. It's going to print it out. Sorry. All right. Then there is bubble sort. It looks a little meaty. It's bubble sort. You guys know bubble sort. So that's what these things do. Now I'm seeing the group does not know malloc. So I'm just going to give you guys a quick overview about malloc. So when you're working at this low level, memory is free. It's literally there's no structure to it. So you will have to write definitions for the structure of memory. You can do whatever you want with it, quite frankly. Obviously, some constraints, but it's very free. So the way you tell C to give you some memory to use is by using this function called malloc or calloc. So I'll show you guys over here, malloc. So what malloc does is it asks, well, technically it asks the C compiler, which might be best in the OS, but on a general level, it just asks from the OS, like, hey, could you give me this block of memory of this size? So in malloc, you ask the size you want it for. For example, it says, give me 15 bytes of memory. No more, no less. That's what it's going to take care of. It technically can give you more, but do not call for it. Sometimes it will give you just how much you ask for. That's actually one of the things I do show about later. So for those of you guys who know how malloc works, that might be a little exercise for you guys. So that's malloc. But once you have gotten that memory, you gotta read at the end of it, right? So that's actually a neat thing. Oh, well, it's not neat, it's kind of shitty, but it's a thing about C. So how in Java you can say integer a equal to 7. You don't have to worry about now you don't have to ask the OS for memory. You don't have to tell the OS hey, I'm done with this. There's this thing called in higher level languages, so Java, Python, JavaScript, all the the top fancy ones. They have this thing called garbage collection. What they do is they see if something you cannot access some variable anymore. So it takes care of freeing it for you. It makes sure your whole thing is running. C does have garbage collection, but that's at the very end. So once your code is done running, that's when it goes in and frees everything, forces it to free everything. That's mostly done by the OS, but whatever. Point is, it's usually fine to not free memory. You need to free it for your project, just an FYI for 240. You do need to free it, otherwise your points will go. So for short programs that run for 5 minutes, you don't care if a couple of bytes you forget to free it. At the end, the OS will just wipe it out. But for programs that run for days or sometimes years, you've got to make sure that they don't take more memory. So you've got to be careful. All the memory blocks you take, you put it back in. So that should be a motto, at least for this class. You know what? Let's just get started. Let's just get started, okay? So first things first, I'm gonna compile it. So let's go here and go. Okay, are there any questions so far?
Sorry, so what does that minus again?
Okay, so when GCC compiles it without the G flag, it won't allow you to debug it. So there are these things called like map. It kind of maps into the line number to where you are running the function. So G flag asks GC like, hey, you just add the mapping so like it's easier for the programmer. So when you'll be actually like you're done writing your code, you're done debugging, and when you want to push it out in the world, remember to remove the hyphen G flag, otherwise your source code is going to go in the world. And if you're getting like it's like a like a protected program, you don't want your source code out in the world. Just say. So does that answer your question?
Yeah.
Okay, you seem unsure.
No, it's fine. Just
No. Go ahead.
I just need a moment to just digest this.
Okay.
It's fine.
All right. If you have something, just let me know. Just interrupt me. I don't really care. And see, I'm not very high in my group. Anyways, let's run beta out. You know what? What's the worst that could happen, right? Segmentation faults. So, do you guys know what seg faults are? Oh, if you guys do not, you're gonna love them absolutely for your final project for 240. Seg faults are when your program crashes. That's period. It's irrecoverable from that point onwards. That's a lot. That's to do with memory. And I'm gonna try to go over this example, but it's kind of hard if you guys already don't know how malware and all these things actually work. They will teach you, which they hopefully will teach you in this class, and you won't have to self-learn. So, seg faults means that you exceeded the bounds of your memory, or you did something wrong. It doesn't tell you what. So that's what I was saying with C. It will tell you that something went wrong. What went wrong? Oh, that just sucks to be you, I guess. C is never going to tell you that. So, but we have GDB. We can be little smarties about it, and we can try to find it out. So the way we do it is GDB, the executable name, and we hit that. We have all these licenses, and we just hit run. And we see we have a seg fault in line 36. All right. We see we have numbers. We are setting the variable I, and we were putting in I plus 1. So let's see what could be happening wrong, right? So let's do a list over here. And here's the function we have. So let's run through it mentally line by line. You're setting numbers to be null. That's a big one. So if you are saying the array to be 1, we do not want that. So that is already we see our issue. But let's just keep going for one's sake, I guess. You're having I set to 0, looping through it, setting the values, setting the last value. So let's just try to see, let's print I. Let's say print variable I. We see 0. Let's say we want to print numbers to see, it won't always be often what's going wrong. It's sometimes what happens is quite often what is actually going wrong was 10 functions away. When it's showing up is right now. You got to figure out the way to go back 10 functions. It's hard. It's not easy to do. But the good thing about us programmers is that we are tough and we keep getting at a problem till we die. So we are going to be doing that. Please don't die. I do not encourage that.
You're on TV.
Don't remind. Anyways, so as you see over here, it points to nothing. It points to 0. 0 doesn't mean anything. So we see our issue. That just means we can go ahead and fix it. So what we do is we just jump over here. We see what the issue is, and we just type out the correct code for it. You guys will get more used to it the more I don't know who's teaching you guys to. So I'm guessing we'll he'll hammer these things in with you guys. You guys will hate him after that, but he doesn't mean well, but he teaches well at the end of it all. Yeah, I know. That's the CS department came up for you. Okay, so what we're doing instead is like, hey, we forgot to ask the OS to give us memory. How can we have that happen? So over here we tell OS like, hey, give me 5 chunks. So get the size of an integer. I never remember what the size of an integer. You guys probably remember it. I just have shit memory, so I just always tell it, ask it what the size is. I say size of integer multiplied by 5, and you're like, hey, because I need 5 integers. That's how I'll just save it. So quick win tip, : W, that's gonna save your file. We go out here, We quit execution because we know if this fails. We compile it again, and we run it again. We go to GDB, we hit run. Oh no, it's a new error. Not a oh no, oh yes. It's always good to have a new error. That means something is going different. Let's see what's happening. So here's where the power of where comes in. Oh my god, what is all this nonsense? It's not nonsense. Well, it is, but not that bad. So, anyways, oh god, why is it not letting me show you guys the whole thing? John? Okay, anyways, so this is your stack trace. This is what's gonna sometimes happen, and you gotta not panic because most of these are internal functions. There is probably 99.999% chance there's not an issue with C, there's an issue with your code. So we look at all of this and we're like, we know all the stuff above is probably working right. So we go all the way over here and we see we have a main function, we have the copy string function, right? That means the main function was simply calling copy string. So we know that can't go wrong. And we are in copy string, so we know that definitely didn't go wrong. But we see there's something went wrong in copy string. Let's try to figure that out. So we go, it's line 57. Okay, so okay, now this is what I was trying to say over here is that you gotta switch the frame. So I just tried to print out what's around. I didn't get anything because I'm not in the correct frame. So I'll change my scope. So I tell it to go to frame, what is it? 30. I hit that, and now I do a list. I see this code. Okay. So actually, you know what? A lot of you guys are gonna be like, why is he doing all this little mumbo jumbo? You're right. So for you guys, I got a little trick thing which I always forget the command about because I never use it myself. So if you hit Control X, Control A, you should go to like a visual mode. I don't know where it's not going now. It was before, I guess. That's technology for you. Anyways, so if you hit Control X, Control A, it goes into a mode like this. So you can see the code over here. You can see the debugging window at the bottom. That's useful, except when it's not. So the issue often happens is that your thing is so small at the bottom. That's the main thing you want to see. I know some of you guys' monitors are like 1 billion megapixels. Mine is not, so I just keep it open in different things. So like I have one open over here, the code open over here, whatever. So we see that there's a different issue happening now. That's good, which means we solved our previous issue. Good stuff. Okay, so we see we are in copy string line number 57. Let's go to line 57 and we see, hey, there's an issue happening over here. What's happening, you might ask? Excellent question. Okay, let's print it out and try to see what's happening. We print copy, right? Let's see what the variables is, right? But it's right. It's perfectly fine. You see it over here. What could be the issue? So this is where I said sometimes C just raises his hand and be like, I don't know what's happening anymore. It's up to you. So this is an example of what you will be encountering pretty frequently later on called so in this form, it's not manifesting it, it's manifesting it differently. So there's this thing called memory bashing. That means you screwed up so big that C doesn't know where it's at anymore. So don't mess up. I'll show you guys why it's happening. So is there like a marker over there? This is probably gonna go a little over time because I didn't think I'd have to explain like malloc and stuff. So if you guys have to head out, no grudges or whatever. So when malloc is gonna return, it's gonna return you a block like this. This is a chunk of memory allocated to you. Now, this is gonna be, for example, say 30 bytes, right? So C has this thing where it says that you can do whatever you want. You can do whatever the frick you want. It's not going to be in your way. So if you decide like, hey, you know what? I asked C for 30 bytes. I don't want 30 bytes. I want 50 bytes. What you can do is that I'm just going to keep writing till I hit to more 20 bytes. You can do that. But then C is going to be like, well, you messed up what I had after this. So I really can't do anything anymore. So C kind of just gives up at that point. So you will learn this in like classes like, so I'm doing 252 right now. So you will learn over there that there is more data, metadata that's at the end of this that allows C to work better. And if you screw this up, you are probably going to screw up your program. It's not most of the time it's not going to show itself up. But when it does, it's going to be real sneaky. So gotta be a little careful about that. So let's try to see what's happening, right? So so first we print actual string. So let's print a string, right? Okay, we see this is the same string. All right. Next, we try to do a size of the string. So it's it's a pointer. Oh my god, this is gonna be it. Okay, never mind that. That's more weird C stuff, but well. The point is at the end of when you read through your code, you'll notice something really unique. How long is the string of characters over here? Pretty long. That's your answer. No, because here's the thing. Try not to. This is like a general pro tip. Try not to hard code stuff. Try to keep it like ask what it is. So like ask string length, ask size of. Because if you hard code it, your users are gonna find a way to just go beyond the limits. It's just gonna end up happening. Like if you tell the users to do something, they're never gonna do that thing. They're gonna do everything but that thing. So always keep dynamic. Try not to make stuff static declarations. So what we see over here, we are saying the max length of the string can be 15. But wait, that string was longer than 15, which means this is what's happening. You're telling the OS, hey, give me 15 bytes over here. The OS is giving you back 15 bytes. But you just decide to be like, oh, I don't want 15 bytes, I want the rest of it. You keep writing, the OS gives up at the end of it. So be careful, don't hard code. That's the gist of this. So this is a really quick fix. What you can just do is like, instead of allocating like max length, you can just ask what the size is. Like, no one's stopping you from doing that. So what you can just do is, it's your length. This keyboard sucks. Keyboard is absolute trash. Save this, but so there's another thing over here where you should, well, even though I know a character, well, I think a character is of 1 byte, I don't trust myself, which is like a me thing, maybe it's by others. So what I do is just I ask the OS, if you're ever uncertain, ask. So over here, I say size of, and I say card, so which is the character. Now, here's why I'm doing that. This is not because I do it on the side, but different machines, different architectures, they have different sizes allocated to integers. So some older machines or some weird variations might have 4 bits allocated, not 8 bits. Some might have 16, some might have 32. You don't know, don't make assumptions as much as you can. So you just multiply, be like, oh, here it's gonna run fine. I just save it. I go over here, I compile it all over again. And now I run GDB again, and now I hit run. Oh, that ran. The program ran just fine. It did not stop anywhere. So till now, what we were encountering was runtime errors. But now we are encountering something more sinister. Logical errors. Your array is not sorted, right? So that's obviously an issue. Why is the array not sorted? Doesn't make any sense. So there are 2 ways to go about doing this. One, you use GDB for this. Or 2, if it's a simple program, just look at the code. It's bubble sort. Come on, guys. So what you do, just open this up and look at it. So stare at this for 2 minutes, and if somebody can figure out what's wrong, let me know. Speak up, I guess. Yeah, go ahead.
It's supposed to be I is greater than or equal to 0 instead of greater than 0.
Correct. So if you see what's happening, and I'm going to show an example with this right now, is it's actually not going to 0. So let's actually see how. So here the code is easy. You guys just seen it. But what if you did use? But what if it's a bigger code? There are some weird algorithms that are recursive and iterative at the same time. It's stupid. So what we do is, one way to do it is to set up a breakpoint. Breakpoints are your best friends. So what I'm going to do is I'm going to go to GDB, set up a breakpoint at line number 72, and show you how it goes. So breakpoint at line 72. So if you have one file, you can just put in the line number. It's going to see like, oh, it's just one file. But if you have multiple files, file name, colon, line number, like I showed at the start. And the cheat sheet covers that too, as do those guys. And what we just do is we try to run from the start, and we stop over here. So we have this. Let's print I. We see the I is 10. All right. So we do that, and let us print the array. So I do p array. All right. So this is the array, right? It's unsorted right now. So what I do is I let it continue. So it's going to keep going till it encounters the next breakpoint, which in this case is going to be the same line for inside a loop. So I hit continue. It's going to stop here again. I print array again. So some stuff is different, I guess, somewhere. No, but hold on. Why is this not different? It should be a little different at least. Okay, yeah. So okay, the last two are sorted. That's why. So what you just do is keep going. I'm just going to hit continue a couple of times. So let's see what I is right now. I is 5. Let us print the array over here. Well, it's starting to look a little more sorted, right? So let us now do something cool. All right. So we have breakpoint 1, and here's what I'm going to show you the if condition, which I alluded to at the start. So I delete. Also, this I didn't use this cheat sheet. Like I have a printout at my room too. So it's fine, just use it. There's really no harm to it. It's a really good thing. I find it convenient. There's a complicated one. If you guys are smarter, go for it. I am not. I use a simple one, but I'm a dummy. Okay. So I go over here. I go to the breakpoint, and I tell you, hey, I don't really care if you go every time. That's not my concern. I just care for the last one, which in this case, I say let's just go to the second last one, which I think is going to be 1. So I say breakpoint at line 72 if I equal to 1, right? So there's the breakpoint now. Hit continue, it keeps running, right? And now when I print I, it's going to be 1. That works, right? Next, so let's just run through it with next. We see it's going to be here, blah, blah, blah. Gonna go to the I equal to J1 line 72. Gonna go in, it sees that the next one is out, it breaks out of this loop. So it's gonna be over here, and let's print I. Let's print the array right now. Right? You see the array, this one needs to be sorted. We hit next, and it's out of it. It shows us that we never go to the I equal to 0. So the fix for this is like super easy, which is literally one character. You save this, and you quit this because it's done, and build it again. Output longer than expected, and this runs just fine. So that's the explanation I have so far. So let's see. How many of you guys could stay a little later? I know this is kind of running a little off, but can you guys stay for a bit? Because I'm gonna keep going. I have like a little more stuff to cover. If you guys can stay, I'd appreciate that. So here's a little XKCD. We don't have time to go through it right now. So there is another file in over here. If you guys look at it, it's called ASCII.c. I wanted to try doing it on your own. I'll be here for like a while longer. You guys can try it on your own, and if you guys can't figure it out, come to me. I'll help you out with that. Okay. So try to do that on your own. Use the things I've taught you so far. I will help you to debug that one. I'm hoping I did put in bugs in there, and I'm hoping they're easy ones. There's that. Now I'm going to teach one last thing, which is not GDB, but it's really useful for 252, which is called Breakpoint. Breakpoint is the last thing you do after you're done writing your whole project. So what Breakpoint does is it allows you to check for memory leaks. So remember how at the start I told you want to return it to the OS? For small things, you can just forego it. But for this class, You really can't do that. You have to free every little thing you allocate. So Valgrind helps you do that. So let's try this readout out, right? So the way to use Valgrind, at least for the purpose of Valgrind, does a lot of different things. The core thing it does is checking for memory leaks. So we run Valgrind, leak. So leak check, yes, and just run it. So this is Valgrind. Let me just try to go through it. I'm going to try to be quick about this. So this is so at Valgrind it says memory error checker. You get the command you're running, and so here it says that you may have learned a mistake over here. You did learn something you shouldn't have. It isn't enough to cause your program to crash, but it's something you shouldn't be doing. I know what the issue is, and if you guys actually know how to use how malware and things work, you can try to debug this. It's not a super bad error, but it's still interesting to look at. But anyway, that is something you also will need to make sure that is not in your final projects for 252 or whatever, but not 252. 240, yeah. So here is what you actually will be looking at will be the heap summary. So this is after your program is done running, it's going to tell you. At the end, we still have 54 bytes in use. We have made 3 allocations, we had 1 tree. And it says over here 20 bytes in one block are definitely lost. So when we look at over here, we see in initialize underscore array. So we go to over here and we see what's the line number? Sorry, 33. So at line 33 is where we declared that block. So we see over here when we allocated, we forgot to free over here. So we just go over here, we hit free, and we say free numbers. I'm not going to run this stuff because it's going to work, but if you run it, that error is going to go. The next one is in another place, same thing. You see where it's allocated, and then you think about where you're supposed to create, where you should be freeing it. And at the end, when you're done, the leak somewhere you should have definitely lost should be 0, indirectly lost should be 0, possibly lost 0, still visible. I think it should be 0. Whatever, it should all look right, which is I know very subjective, but you just get used to it. You just start seeing everything is 0. It probably is fine. So yeah, that's Valgrind. We'll need to use it. Pretty important, I would say. But I think that's it. And the example I said, ASCII.c, try it. I'll still be here. We'll be around. If you guys have the time, do it. You guys did clone that. Do it on your machine. Do it on data.cs. Do it on the leaflet. I don't care. Just do it. So before you guys leave, scan this form. Scan the event form. Tell us how it went. I'll have this open. Join our Discord. I'll have the form open again. So if you guys want to join the Discord, which is sure, come on to me. I'll be sure I can't do split screen type. Have a great rest of the evening, everybody. I hope to see you for our next workshop. Yep. Yeah. All five. Yeah, what's up?
It was good. I couldn't keep up with everything, but now I know
So that's
how to debug line by line. I'm actually looking more into some stuff.
So you must decide
Setting up what the
so you can you have settings, you
I gotta go talk to the
You need to
it, it's a technical installer, it allows you to use a mouse or a keyboard. It's really cool. So would highly recommend installing that.
That was great. You're a really good speaker. I should stop there.